Hey there, the purpose of this video is to derive the derivative of sine using the h definition, and then to get you started on the derivative of cosine, and then show you that derivation to make sure you actually did it correctly. So in the process of doing this derivation, we're going to need to use a trig identity that you learned last year. And that identity is this one, that the sine of a sum of two angles is sine of the first angle, cosine of the second angle, plus cosine of the first angle times sine of the second angle. Now, this is the only time really all year we're going to use this identity, so don't worry about going back and memorizing it. Just know that it's true and that we're going to use it. So I'm going to start this process of finding the derivative of sine by using the h definition. And remember, the h definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. So in this first step, I've shown where I've plugged those things into sine. This is f of x plus h. This is f of x all over h. Now, this part right here gives me sine of a sum. So I'm going to use this identity up here to break that apart. And that would look like this. Now, you see this sine of x cosine of h? You see this negative sine x over here? Those have a common factor in it. So what I'm going to do is I'm going to take those two terms and I'm going to put them next to each other and pull out that common factor. Now when I do that, that's going to look like this. Notice that I pulled the sine of x out of the cosine of h times the sine of x. That's this. And from the negative sine of x, I pulled out sine of x and left me with negative 1. And then this term here that didn't have a sine x in it, I just moved it to the end. All right, so what I'm going to do with this now is I'm going to manipulate this fraction so that all the stuff that has h in it is together and all the stuff that has x in it is sort of popped off. So if you look at this first part, there's a sine of x here, no h, and then you have this cosine of h minus 1 over h. I'm going to break those apart and you'll see that in the next step. And if you look in the second part, there's a cosine of x and then there's a sine of h over h. So breaking all those things apart would look like this. The sine of x gets popped off, the cosine of x, h minus 1 is here, and then the cosine of x gets popped off, and the sine of h over h is here. Now, I'm ready to take the limit of this stuff. So if I let h go to 0, sine of x goes to sine of x. There's no h in it. If I let h go to 0, cosine of h minus 1 over h, if I plug 0 in first, that substitution thing, I get 1 minus 1 over 0. So that's 0 over 0, right? And 0 over 0 is an indeterminate form. So we don't really have a way of dealing with that yet. We will, but we don't have a way of dealing with that yet. So we're going to deal with that limit in just a moment. The limit as h approaches 0 of cosine of x is cosine of x, again, no h. And then the limit as h approaches 0 of sine of h over h, again, gives you an indeterminate form because it gives you a 0, sine of 0, over 0. Again, we don't have a way of dealing with that just yet, but we will. But we're about to figure out what the limits are, just not analytically this time. So if I don't have a way of getting an analytic limit, one of the ways I can actually look at it is to try to find the limit graphically. So I'm going to look at this cosine of h minus 1 and the sine of h over h and try to get those limits graphically. So I'm going to pop over to Desmos for a second. So you see I've got sine of x over x, because Desmos only recognizes x's, not h's, and 1 minus cosine of x over x. Again, doesn't recognize h's. So I'm going to turn on the graph of sine of x over x first. Now, if you look at what happens as this graph approaches 0 from the left and from the right, you can clearly see that those y values are approaching 1. Now, at that point, at 0, it's undefined. But the limit from both sides is getting closer and closer to 1. So the limit as x approaches 0, sine of x over x, is 1. We'll use that back in the proof. If I turn that off and turn on 1 minus cosine x over x, that would look like this. And if you look at what happens as x approaches 0 here, the y values get closer and closer to 0 from the left and from the right. And again, at 0, it's undefined. But the limit gets closer to 0 from both sides. So this limit, as x is close to 0, would be 0. So now let's go back to the derivation. So what we just saw is that this is 0, and this is 1. And we show that graphically. So when I do that limiting thing, this is what I get. Again, sine of x, that one went to 0. Cosine of x, and that one went to 1. When you multiply sine x by 0, it goes away, and so the derivative of sine is cosine. Now, the derivation of the derivative of cosine is really similar. Except this time, I'm going to use a different identity. And that is this one. Cosine of a sum of two angles is cosine of the first, cosine of the second, minus sine of the first, sine of the second. And now that we've shown these limits are true, I'm just going to go ahead and include those as something that we know, because they'll pop up again in this derivation. So what I'd like you to try to do is to go through the process that we just did with sine, with cosine, and see what you get as a result. If you get stuck at some point along the way, unpause the video, and I'll go ahead and show you what the derivation looks like.